Welcome everybody, and we'll just jump right in here with the presentation. So the big challenge in Industry 4.0, or IIoT, Industrial Internet of Things, as it's often called in North America, is unifying data across legacy systems. Most legacy assets, machines, and systems were not designed to connect beyond the plant networks. This separation causes silos of information between the plant floor operational data and IT and all of the other back-end systems. So what about wiring? This is often complex and very expensive. One customer, in fact, told us that the quickest way to kill a project in their plant is to say it needs to be wired. Their average cost calculation is that a wired sensor requires $20,000 to $50,000 per connection when all the pieces are taken into account. So things like wiring, racks and rails, routing through concrete and metal, approvals, and all the departments that need to be involved. So engineering, electrical, IT, safety, QA, etc. Plus it's a long time. Another partner that we work with is also seeing that 20 to 30% of PLCs are not connected. So what does one do to get the data that they need to connect it to, the operational data to the information technology data? A lot of people have looked at legacy wireless solutions, things like LoRa, Sigfox, MBIoT, Wi-Fi, and Bluetooth, but they have some or all of the following limitations that we'll go through. So for instance, they may have hardware dependency rather than software focus, so things like LoRa and Semtech run on the Semtech chip. Sigfox has a proprietary chip, so it doesn't allow you to scale into different solutions, and you have vendor lock-in. Commercial carrier fees and proprietary third-party managed networks also increase cost. Things like LoRa or Sigfox are third-party. For LoRa, for large deployments, you need a third-party network management provider. Sigfox runs across their own proprietary network, and a lot of our commercial industrial customers and partners tell us that they won't allow their data, their operational data, to go across third-party networks. They're also concerned about the security risks there as well. So it's cost and security risk in this case. And that they have low interference resistance and high bandwidth demand. So things like LoRa and Sigfox have poor interference resistance. They get interfered with very easily, especially in shop floor environments with a lot of electromechanical interference, a lot of metal and concrete and things like that. They can't penetrate through those environments. And also they don't play well in the sandbox with others. A few of our large industrial partners and customers have tried out all the solutions at once and found that some of the others will interfere with their existing Wi-Fi or their existing solutions such as Bluetooth and Zigbee or other RF on the shop floor already. For those of you that tried, you know that the easiest way to interfere with a LoRa network is to place another LoRa network beside it, so they interfere with themselves. They also have high power consumption, which causes low battery life. So LoRa and Sigfox, certainly as LPWAN solutions, have a longer battery life than MBIoT and 4G and LTE solutions, or Wi-Fi and Bluetooth, but not as long as the solutions that we're going to be talking about shortly. They also have limited support for moving sensors. LoRa, Sigfox and MBIoT cannot be moving at all, so 0 kilometers or miles per hour. LoRa can move up to about 30 kilometers an hour or about 18 miles an hour, maximum speed and reliably delivered data. And the scalability is limited to hundreds of devices on a single gateway. In the case of Sigfox, you can have more, but you can send 2 to 6 messages a day, so very limited scalability. So in the end, these solutions are not scalable and don't work well in industrial commercial environments. That's where MYTHINGS addresses the issues of those legacy wireless solutions. So at the core of MYTHINGS is the MYOTI protocol, the TSUMB 103357, where if people want to go look up the ETSI standard, you can go search their site and see the 130 odd pages that describe that standard there. But what this means, in other words, is MYOTI and the protocol underlying MYTHINGS is the only standards-based LP WAN on the planet today. So let's take a look at what makes MYTHINGS different and why it's a great fit for industrial commercial applications. I'll briefly explain the power of telegram splitting and what it is. It's the secret sauce really behind MYTHINGS and the MYOTI protocol. It is the patented technology, and it took a long time and a lot of development to do it. This simple idea took 10 years to develop, and it gives you a lot of great performance characteristics that we'll jump into in a second. But first, a brief explanation without getting too technical, without going into 130 pages of a technical document. If you look at traditional LPWAN, something like LoRa or Sigfox in this case here, the data packet here is on air. For this case, it's a single frequency, takes up the whole bandwidth, and goes on air for 2 to 6 seconds. The problem with that long on air time is a few things. The chance for an interferer are greater, and if you get an interferer in that environment that collides with the data, you lose the data and it's not delivered to the receiver. The other thing is, with a long on-air time, the battery life is diminished on the transceiver as well, on the sensor in most cases. So what does telegram splitting do? We'll take a look. We take that same data packet, the blue line, we break it up, we chop it up into little sub-packets, and we distribute these sub-packets over frequency on this axis and over time. And these little sub-packets have 16 millisecond on-air time, and that does a few things. Again, what it does is reduces the chance of an interferer, and even if there is an interferer, what we do with the sub-packets is we put forward error correction on each sub-packet. And so even if 50% of the sub-packets are interfered with, we still deliver the data. And then lastly, because of the short on-air time, it gives you that battery recovery, so you have a much longer battery life. And this leads to a bunch of different performance characteristics amongst the differentiating from the legacy systems out there in LPWAN. It gives you unrivaled interference immunity because you're split up over those frequency and time, and it is a random algorithm. Gives you that great building penetration as well. Longest battery life of any LPWAN solution. So for example, about 4 times better than LoRa, 16 times better than a Sigfox on the similar same amount of data being transmitted. You can aggregate millions of messages on a single gateway from thousands or tens of thousands of devices. In North America, where there is no duty cycle, we can handle 11.5 million messages per day on a single base station. So you can just take that and divide by the frequency, how often you're sending, and the number of devices, but it's thousands or tens of thousands of devices, depending on how often you're sending. And then you can also collect data from moving sensors and gateways at up to 120 kilometers an hour, about 75 to 80 miles per hour. And we have some folks that have tested this on trains in Europe, and they've done 2 things. Trains have a lot of metal and difficult environments to send signals through. We could both get the data out, and while the trains were moving, we could also receive the data reliably and get the data that we were looking for, and of course run for a long time on a battery. So again, all of these things have been tried out in the field. MYTHINGS provides an end-to-end solution from the sensor to your network with we have the stacks for the sensors and transceivers. We can connect to base stations or multiple base stations. The sensors or endpoints can be connected to multiple base stations. And then we have the MyThings Central that manages all of those environments. So the real key is that we're a software vendor, and we think of this as a software solution. And the MyThings Central comes with a MyThings system, and that gives you some options like endpoint device management and provisioning, data description language for the sensors. So, and it's vendor agnostic. So we have a JSON file descriptor for all of those. So when you connect a sensor to the base station, we already know what the data is coming through and what format it's coming through in. It's a API-driven design. We have flexible interfaces through MQTT, WebSockets, or RESTful APIs. It's a customizable UI. We don't need to own the desktop. We certainly provide you with all the features and functionality that you need through the UI. But if you want to integrate it with existing systems, legacy systems that you already have in place, say for provisioning or something like that, the APIs are all available there, and you can do that if you wish. And you don't have to use our UI. Plugins for AWS, Azure, Cumulocity, and others that can be built easily to support kind of that end-to-end network. So we think of this as network management, and it's built into all of our solutions. This is not a homegrown type solution or build your own, such as what you see a lot of in the LoRa environment. And that provides flexibility to choose your own transceivers, gateways, and application platforms, as well as avoiding the cost of those third-party managed networks, and also the privacy and security issues of third-party networks. So you have it all built into one system. One ecosystem provides you end-to-end solution. It's a one-stop shop. So to sum it up, on the technical side, it provides you with that long range. It gives you 1 to 15 kilometers typically, so up to 10 miles generally in normal environments. And so typical to other LP WAN systems. And of course, there's those crazy use cases where you can get a 60-kilometer range if you put the antenna up on a mountaintop and there's line of sight and nothing in between. But in normal conditions, what we're seeing is 1 to 15 kilometers and between 3 to 8 kilometer range in dense urban environments like a big city like downtown Toronto or other urban centers. So long range. The low power, as I said, again, 4 to 16 times better than like a LoRa or Sigfox. NB-IoT and cellular solutions have much shorter battery life, not really comparable at all to LP WAN. So they have very short battery lives. The scalability with 11.5 million messages a day on a single base station, so thousands and thousands of devices. That second to none robustness, quality of service, the unparalleled radio frequency delivery of data, and the exceptional mobility moving up to 80 miles per hour, 120 kilometers an hour. From the business side, you're working with a system that is based on a worldwide standard with built-in security and data privacy. It is an open solution, allows you to use different hardware. You're not, vendor locked in. The cost efficiency with one base station piece of infrastructure supporting thousands of devices makes it cost efficient and very easy to install. We have integration modules with brownfield sensors, and also we can have built greenfield or new sensors, and we have full out-of-the-box kits that are ready to go as well. So those are the differences of MYTHINGS and what makes it a great solution for industrial, commercial, and in the Industry 4.0 and the industrial Internet of Things. And with that, I will pass it over to Dr. Saeed Farahani with the use case from Clemson University.
Thank you, Michelle. Hello, everyone. Thank you for attending in this webinar. So within the limited time that we have here, I'm going to share a little bit of our experience in using IoT solutions in plastic and composite manufacturing. Basically, I just want to give you an idea how to use these new technologies uh, in actual implementation condition. As you know, the Internet of the Thing is part of a broader collection of technologies that is known as Industry 4.0. That's why first I need to explain why we need Industry 4.0, particularly for plastic and composite manufacturing. In the other word, what are the motivations behind using these new technologies, including IoT solutions? The answer for this question can be divided in two sections. One part of the motivation comes from the process complexity. As we know, plastic and composite manufacturing processes are very challenging. Imagine we have vast possible combination of the fibers, fillers, and polymers. And if you have a specific application, it is almost impossible to find an optimum material solution. You may find a material combination which works well for you, but you never know that this is the optimum solution or not. Another complexity is the multi-physic nature of the process, manufacturing process in plastic and composite. Imagine, or for example, you can consider injection molding process. It has been around for almost 100 years. But the modeling and simulation of this process is still challenging. That's why you see every year or several times per year that the software companies release new updates on that. And still in all the application, their modeling and their prediction is not very reliable. Accordingly, tooling and machine research system is also complex. So if in any way we can use these new technology to reduce the process complexity, that would be very valuable. Another part of the motivation comes from the industrial need. As you know, high performance plastic and composite material, they have a superior mechanical and thermal and corrosion resistant properties. But their main drawback is the high cost of such materials and their manufacturing process, which has been limiting the application of these materials in cost-effective industries such as automotive industry. That's why we need to utilize these new technologies to improve quality control process in order to have more efficient and flexible production, or even to accelerate the development of the new materials. Any way that we can use this technology to reduce the final cost of the plastic and composite material, that would be very valuable. Now, as we know why we need Industry 4.0 and this new technology, now is the time to see how we can implement these technologies. In plastic and composite manufacturing environments, similar to the other types of the manufacturing, we have a set of machines and devices. Plus, we have some external sensors, or we can potentially install external sensors. There are also some manual operations which are very important sometimes, especially, for example, if you use a manual quality control process. So if we can collect data from all these different types of the data sources, and more importantly, if we can unify this data while we are keeping the temporal and spatial correlation of the data, then later it is possible to use physical relation, statistical or AI-based method in order to convert this data into the information. This is one part that the role of the academic important is very critical, because the domain knowledge and having the knowledge of that specific manufacturing, or here plastic and composite manufacturing, would be very important. After we converting data to the information, this information can be feedback to the machine as a real-time process control, as a closed loop process control. We can use this information to build manufacturing execution system in order to track raw material, to track the manufacturing process from the raw material up to the end of the process, which is the final production. Even we can send this information to the highest level of the enterprise in order to make decision based on the manufacturing data, which is very important. So the implementation of this new technology is not as easy as I have mentioned in the previous slide. And of course, there are some challenges. Part of these challenges comes from the equipment and sensors. In terms of the equipment in plastic and composite manufacturing, we have a wide variety of the machine, tools, auxiliary equipment, and devices. That's why we always see different communication protocol in one single manufacturing plant. So unifying and integrating the collected data becomes so challenging. As I mentioned, especially if you want to keep the temporal and spatial correlation of the different pieces of the data. Another challenge is the legacy equipment. If you have equipment that has been constructed more than 5 or 6 years ago, most probably this equipment, there is either no connectivity or very old style text-based communication protocol. These equipment, sometimes they are very expensive and they functioning very well. So that's why no one is willing to replace these equipment only to bring connectivity or sensing features. So another challenge is the lack of enough knowledge about the external sensors. For example, we have too many sensors without any selection criteria. In terms of the, for example, in terms of the in-mold sensors or in-mold instrumentation, we have variety of different pressure, temperature, strain gauge, direct, indirect, or contactless sensors. And really, there is no specific criteria how to select a sensor for a specific application. Another challenge is the lack of knowledge about the accuracy and durability of these sensors in complex and sometimes harsh industrial environments. Now let's see what are the solutions for part of the aforementioned challenges. So if there is an equipment with a legacy or if there is a legacy equipment with the older style communication or even just with the PLC, one solution is to connect a edge gateway to that PLC and directly get data from the PLC. Another solution, if that equipment is even older and there is no connectivity features on that, or it's a simple device and there is no PLC on that, we can use some smart sensors in order to detect the special process variables that is critical for that data processing goal. So we can just collect that data from the equipment. And then later, after we collect that data, we can send this data to the base stations. And the good thing about this MYTHING technology is that later you can scale out this data using any cloud-based system in order to use that data for data visualization or monitoring or even data analytics process. So far, we have one successful example of using MYTHINGS technology in our research application. Particularly, we use their smart sensors to remotely collect data from downstream equipment of the extrusion process. By integrating this data with the data that we could directly get from the extrusion machine, we could develop a system to calculate the energy absorbed by the plastic material during the compounding process. So why this energy is important? Because previous study shows that there is a direct correlation between the amount of this energy and the degree of the crystallinity of the material. That's why if we can control the process in order to keep this energy consistent, then we can expect to have more consistent material property on the final compounded plastic, which is very valuable. So we are currently working on using their technology in order to retrofit legacy injection molding machine and their tooling system. And hopefully soon we will have a result also on this work. And I think by this, we reach to the end of this presentation. And thank you for listening. And I hope that you find it useful and informative. So please feel free to ask any question from me or Maisha.
Thank you so much, Saeed. If you do have any questions, please feel free to type them into the question box on your GoToWebinar panel. I do see we have a few already, so I will kick us off. The question is, do you have a solution today for PLC integration? I think that's a question for Michelle.
Sure. Yes. Thanks, Courtney. Yes. We have an integration point. We have what we call a PLC integration gateway. It's a small piece of compute that can plug in via Ethernet port to a PLC. It has our built-in transceiver, some software that will read and tag the data. So no programming required. It's just reading the data. Of course, you don't want to change anything on a PLC. So we just tag the data, pull it off, and send it via our transceiver to the network, so to the base station. So yes, we do have a solution that works with that today.
Great. And a related question, aren't all PLCs wired in most manufacturing facilities nowadays?
Yeah, good question. Yeah, I made that assumption a couple of years ago as well. And then I started touring a lot of them manufacturing plants. And in fact, one of the newest auto manufacturing plants in San Luis Potosi, Mexico. A large German car manufacturer built a new plant there, and this was last May. It opened, and I assumed that everything would be connected because it's new. Well, in fact, 20 to 30% are not connected at all via wire or wireless connection. So and working with our partners who provide solutions in PLCs and PLC monitoring, they're seeing the same thing. So that's why they are working with us. There are in fact many systems, and the older plants are even more less connected. So the number goes up to 40 or 50% where people are doing manual checks on all the equipment daily.
Okay, and we have a question about MyThings Central. So they're asking for a little bit more information around the network management piece of MyThings.
Yeah, and I went quickly through that in my presentation, but the MyThings Central is really the core piece of our software. It manages the entire network, so it can see, it can reside either on the base station or in a cloud environment on premise, and it manages those endpoint devices, so provisioning and management of them, managing the multiple base stations. It has that data description language is for the sensor. It is an API-driven design, flexible for interfaces for MQTT, WebSockets, and RESTful APIs. The customizable UI to make it your own solution if you want. And again, plugins to get the data off for things like AWS, Azure, Cumulocity. We have a lot of requests for IBM Watson coming soon, and some others as well. So as well as the native MQTT integration. So that is the core of MyThings, the MyThings Central component.
Great. And another question. So this one says, extra long range, for example, 80 kilometers, or no line of sight is a requirement in some use cases. How can mesh network capability be used on MyThings?
Yeah, so MyThings and the MyOT protocol are not mesh networks. There are some. It is a star topography, so it's the sensors endpoints to one, and there's pluses and minuses of star topographies versus mesh. Mesh have single point, the transceiver receiver points. Some of them can have points that are single points of failure. Also, because they're taking in and sending on data, the mesh networks use a lot more power. But we are looking, so we are star topography, not mesh, but we're looking at ways of connecting base stations from one base station to another to give the longer range. But the other option that we have is a cellular or satellite backhaul from a base station. So in those edge use cases where longer distance is required, we can do that as well. Any other questions?
Yep, I have this one. Can MyThings integrate with other IoT chipset providers, sensors, and products?
Yes, the short answer is yes. We run unidirectional right now on a TD Next module that's fully certified FCC CE. So both North America and European frequencies. And we're supporting chipsets, the TD Next module, also Silicon Labs, FlexGecko chipset, as well as soon the Texas Instruments 1320 chipset. Both in bidirectional mode. So you can run those, and you can run MyThings Central, the receiver part. We have a commercial off-the-shelf ruggedized or semi-ruggedized gateway, but you can also run that on other gateways if you want as well.
Great. We do have quite a number of questions, and I know we've run a little bit over time here. So what I am going to do is I'm actually going to get Michelle or Saeed to follow up with all of your questions after the webinar. And of course, if you don't, please don't hesitate to reach out to us too if you do have any further questions. But thank you all so much for joining us today. Thank you to Michelle. Thank you to Saeed. We really appreciate you all being here. And a copy of this webinar will be sent to you within the next 48 hours.
Yeah, and I'd like
Great.
to thank our partner CGF for sponsoring this session as well. And any of us can answer any questions for you, so feel free to reach out directly.